Welcome to SS2 Physics, Term 3, Week 2. When you plug your phone charger into a socket, you are using alternating current. The voltage and current are sinusoidal, oscillating back and forth 50 times per second in Nigeria. But how do we specify the effective voltage or current for an AC supply? The answer is the root mean square, RMS, value, the topic of today's lesson. By the end of this lesson, you will define peak and RMS values of AC voltage and current, derive the relationship between peak and RMS, calculate power in AC circuits, and solve WAEC type problems on AC electricity. Let us begin. An alternating current, AC, source produces a voltage that varies sinusoidally with time, V equals V0 sin, omega t equals V0 sin, 2 pi ft, where V0 equals peak voltage, maximum voltage, in volts, omega equals angular frequency equals 2 pi f, rad/s, f equals frequency, hertz, cycles per second, t equals time, seconds. Similarly, the current varies as I equals I0 sin, omega t, where I0 equals peak current. In Nigeria, the main supply has frequency f equals 50 Hz, 50 cycles per second, period t equals 1 over f equals 150 at equals 0.02 s equals 20 milliseconds, nominal voltage equals 240 V, this is the RMS voltage, see below. The waveform is a sine wave, it oscillates symmetrically between plus V0 maximum and V0 minimum. The average value of a full sinusoidal cycle is 0, because the positive and negative halves cancel. This means we cannot use the average of AC to compare it with DC. A zero average would imply no effect, yet AC in a heater clearly produces heat. We need a different measure of the effective AC value. The RMS, root mean square, value of an AC current is the equivalent DC current that will produce the same heating effect, and therefore the same power, in a resistor. Derivation of RMS, power dissipated in a resistor at any instant P equals I2 R equals I0 superscript 2 R sin superscript 2, omega t. Average power over a full cycle, PAV equals I0 superscript 2 R times, average of sin superscript 2, omega t. The average value of sin superscript 2, omega t, over a full cycle equals 1/2, can be shown using integration or identity sin superscript 2 x equals 1, cosine 2x/2. So, PAV equals I0 superscript 2/2 times R equals I0/square root 2 superscript 2 times R. The RMS current, AMS equals I0/square root 2 equals I0 divided by 1.414 almost equals 0.707 times I0. Similarly, the RMS voltage, VRMS equals V0/square root 2 is almost equal to 0.707 times V0. The peak value in terms of RMS, V0 equals VRMS times square root 2 equals 1.414 times VRMS, I0 equals AMS times square root 2 equals 1.414 times AMS. Main supply in Nigeria, VRMS equals 240 V, so V0 equals 240 times square root 2 is equal to 240 times 1.414 is almost equal to 339 V. This means the Nigerian mains voltage actually swings between plus 339 V and minus 339 V, even though we call it a 240 V supply, that 240 V is the RMS value. UK mains, VRMS equals 230 V, USA mains, VRMS equals 120 V, power in AC circuits P equals VRMS times AMS, for purely resistive loads. Since VRMS equals AMS times R, Ohm's law applies with RMS values P equals AMS superscript 2 times R equals VRMS superscript 2/R. These are the same formulae as for DC, using RMS values instead of DC values. Worked example 1, the main supply in Nigeria has an RMS voltage of 240 V, calculate A, the peak voltage, B, the peak-to-peak voltage. Solution. A, V0 equals VRMS times square root 2 is equal to 240 times 1.414 equals 339.4 V is almost equal to 339 V. B, peak-to-peak voltage equals 2 times V0 is equal to 2 times 339 equals 678 V. Worked example 2. A household iron is rated 1000 W at 240 V RMS. Calculate A. The RMS current, B. The peak current, C. The resistance of the heating element. Solution. A. P equals VRMS times Ms. Ms equals P slash VRMS equals 1000 divided by 240 is equal to 4.17 A. B. I0 equals Ms times square root 2 is equal to 4.17 times 1.414 equals 5.90 A. C. I equals VRMS slash Ms equals 240 divided by 4.17 is equal to 57.6 omega. Or, I equals VRMS superscript 2 slash P equals 240 superscript 2 slash 1000 equals 57,600 divided by 1000 is equal to 57.6 omega. Worked example 3. An AC source has a peak EMF of 170 V and a frequency of 50 Hz. Write the expression for the instantaneous voltage. Solution. VRMS equals 170 slash square root 2 equals 120.2 V. Omega equals 2 pi F equals 2 pi times 50 is equal to 314 rad slash S. V equals 170 sin 314 T. V. Applications distinguishing AC from DC. DC, direct current, battery-powered devices, mobile phone charging, LED lighting. AC, mains/grid, household appliances, motors, long-distance power transmission. Why use AC for power transmission? Transformers only work with AC, they require changing magnetic flux to work. Step-up transformers can increase AC voltage to very high values, e.g. 11,000 V, 33,000 V, 132,000 V. For long-distance transmission, high voltage means low current means low I superscript 2 are losses in the cables, then step-down transformers reduce voltage at the consumer end. Rectification is the conversion of AC to DC, required because most electronic devices, computers, mobile phones, radios, need DC. A diode is a semiconductor device that allows current to flow in only one direction, from anode to cathode when forward biased. Half-wave rectification, one diode in the circuit, only the positive half of the AC cycle passes, the negative half is blocked. Output is pulsating DC, goes from 0 to V0 and back to 0, but never goes negative. Average output voltage equals V0 slash pi is almost equal to 0.318 times V0. Full wave rectification uses 4 diodes in a bridge rectifier configuration. Both halves of the AC cycle are converted to DC, the negative half is inverted, so output is always positive. Average output voltage equals 2 V0 slash pi is almost equal to 0.637 times V0. Smoothing. A large capacitor is connected in parallel with the load, it charges during the peaks and discharges between peaks, smoothing the pulsating DC to a more constant level. The ripple voltage is the residual AC fluctuation after smoothing. Key points: AC voltage and current vary sinusoidally, V equals V0 sin omega t, I equals I0 sin omega t. Peak values, V0 and I0. RMS values, VRMS equals V0 slash square root 2, Ms equals I0 slash square root 2. RMS is the equivalent DC value given the same heating effect. Nigerian mains, 240 V RMS, 50 Hz, peak voltage equals 240 square root 2 is almost equal to 339 V. Power in ACP equals VRMS times Ms equals Ms superscript 2 R equals VRMS superscript 2 slash R, same formally as DC using RMS values. Rectification, half wave, one diode, or full wave bridge, for diodes, converts AC to pulsating DC, capacitor smooths the output. AC used for power transmission because transformers, which require AC, can step up voltage to reduce transmission losses, I superscript 2 are power loss. WAEC commonly test, calculating V0 from VRMS, calculating Ms and P for an appliance, writing the expression for instantaneous voltage, explaining why AC is used for power transmission.